to you. The chapter will then teach you about light, teach you about sound, and at last the chapter will take you to electromagnetic waves. Those are the 3 units. So our first unit is now to understand general properties of a wave. Okay? You know a little bit about oscillations and all, but anyways, we'll cover them all once again out here. Okay, let's now see. The first thing that we will try to learn today is called classification of waves. 1 minute, huh? As usual. I can help it. Give me a minute. Okay. The first thing that we will study is known as classification of waves. Then when you read your chapter, things will be clear. We classify waves under 2 categories. One, we will classify waves on the basis of medium. This is the basis on which we are. The first way of classification is the basis of medium. What is medium? Medium is the environment through which the wave is traveling. Medium is the environment through it. Now, this is a very dicey definition. Okay. So, if you have like a medium can be an air, a medium can be, say, water. Are you getting it? And if there is no medium, number 2, if there is no medium, then an example of it would be something like vacuum. Vacuum means there is no medium. It is the zone through which the wave will travel. The wave may travel through air, which is most common. You are hearing to me because I am speaking to you right now. There is air in between, and the wave is traveling through air, whether you can see me. Sunlight is reaching us from where? From the sun to the earth, to the vast space which does not have any air or any atmosphere, vacuum. You understand? So on the basis of medium, when we will actually classify waves, we will classify waves under these names. Okay. One, we will call them, the ones which use a medium are known as mechanical waves. Okay. What are mechanical waves? Mechanical waves are those waves which need a medium for propagation from source to destination. Otherwise, the mechanical wave cannot travel. Example would be sound waves. Sound waves. So say suppose both you and me, we go to space, and can we talk and can we hear each other? No, we cannot hear each other at all, because there is no medium out there. One of the examples, and another thing that everybody in childhood must have done, if you have taken a steel glass or a steel bowl, okay, in childhood we used to do is to put it in our mouth and you can suck it inside. Are you trying? You're getting it? What I'm trying to say? We used to, after seeing Ramayana and all, we used to behave like, yeah, main Hanuman ban raha hu. So take one small glass or take a bowl and put it on your mouth and you try to suck that glass. So what you have done, you have sucked the entire air. It's now vacuum inside it. At that time, you try to scream. Your voice is not heard. Your voice becomes very feeble. Why? Sound cannot travel through vacuum. Are you getting? That's you cannot create 100% vacuum. But the way you're speaking right now, you can go home and do it today. Don't take any porcelain cup, you'll break it. Take just a steel katora or a steel glass and put it on your mouth and try to suck it so that the steel glass is held on your mouth in this manner. And now try to, if you talk, it will fall because air gets inside. Try to scream. Your scream won't be heard. Sound waves. Have you understood? Water waves. Water waves travel in water because they need a medium to travel. So is mechanical wave clear? Mechanical waves are those waves which need a medium to travel. Such a medium can be air, such a medium can be water, such a medium can be glycerin, anything, but ek medium to chahiye. Okay? And then let's see the ones which do not need vacuum and then can travel. One of these waves are known as, this is known as electromagnetic waves. Electromagnetic waves. This will be our third chapter in this unit. Electromagnetic waves are waves which do not need any medium for propagation. Example, as I told you, What are you getting from the sun? See, इसका example कितना clear हो जाएगा अभी. From the sun, what you get is something known as EM wave, and I used to call it as the electromagnetic spectrum, right? So if anybody tells you, give me an example of electromagnetic wave, light, infrared, gamma rays, X-rays, radio waves, microwave, all of them are examples of electromagnetic waves because they are all coming from sun. And between sun and me, right now we have a vast space which does not have any medium at all. Is this clear? Right? Our chapter initially will be talking more with mechanical waves, because after this we are going to study about what? After this we will be studying things like what you call light as well as sound. So sound is studied first, or say light. So we'll be talking initially more with mechanical waves. We have got an entire chapter on electromagnetic waves. So I'll right now not discuss much. I've given you a fair bit of idea what is electromagnetic waves in the last class. Even in the heat class also we have spoken about it. Is this much clear? Okay. Now let's see what is the mechanism of wave in a mechanical wave. Okay, what happens in a mechanical wave? So let's talk about a mechanical wave. Now, whenever we speak about wave, so one thing that should hover in our mind is that wave is always due to some sort of a periodic disturbance. Periodic disturbance where the period is constant. This is periodic. This particular noise that I'm making, this also can be represented in a wave, and it will follow a wave motion. But if you talk, इसमें wave नहीं है, periodic, because you can predict wave motion. Okay, now let's see a mechanical wave. Now, have you heard about something called domino effect? Do you know the word domino effect? If you have a lot of cards, we play with this playing cards. You can keep those cards. एक कार्ड को हिला दिया तो ट्रर गिरना शुरू हो जाता है ना. That is called domino effect. Now, understanding mechanical waves is very easy. And let's have 10 kiddos. You make them sit close to each other, shoulder to shoulder hugging, all nursery kiddos, and you start making them sit together in a bus. 10 or 20 kiddos आप ले लो, and you start tickling the first kiddo on his waist. वो हिलना शुरू करेगा, and then he will pass on the disturbance to the other one. Half a minute or something later, you will see that the entire line of children, everyone is doing. But we are not tickling any other child. We are just tickling the first child, and a periodic tickling. And you will see that the entire disturbance is propagated. That is the very basic funda of, even a sound wave. Now we need to understand that. Now what is happening in sound waves? Like, let's take the example of a sound wave now. When we are talking about mechanical waves, let's take the example of sound wave. Now, suppose we have a person, okay? This is a person, and this person is speaking. What do we have in front of this person? Air molecules. So this person is speaking. Sound wave is a sort of a pressure wave. जब ये आदमी बात करता है, hello, he speaks. He actually applies the pressure. There are, now I'll draw 2-3 scenarios. Okay, these are the, say, the molecules which are present in front of him. Okay, let's say, oh, sorry. So let's say, yeah, this is. So let's say, the copy used to be here only. Yeah. So these are the air molecules in front of the person. Just imagine. Now these air molecules will show a bit of an elastic nature. As soon as you start speaking, this person, so let's say this person has uttered some voice. So these will create a zone of compression out here. ऐसे इनको compress कर देगा. Right? As soon as you compress, so you will get a small section which will undergo a region of compression. But they are like elastic in nature. As you compress them, they will again try to exert the elastic force, as a result of which immediately next, you need to visualize this, the compression will be transformed to this zone. Are you trying to understand? I have compressed zone 1 right now, but zone 1 itself also has its elasticity. So it will try to retract. As it tries to retract, the compression gets passed on to zone 2. मेरे को आपने दबा दिया, मैं फिर फैलूंगा ना, जैसे मैं फैल रहा हूं, लुक एट द पर्सन बिसाइड, he is getting compressed. So a zone of compression and the other zone, the compression zone is the zone where you are forced. Here you are actually, this is the zone where you are constrained. Constrained means आपको दबा के रखा है, आपको दबा के रखा है, तो दूसरे वाले में आप कैसे हो, you are relaxed. This is at a particular instant of time. Immediately what will happen, the roles will shift. Because once this fellow has got compressed, he will also again try to expand. When he expands, he gets compressed. So this zone will be called my zone of compression in the language of wave. This will be called compression. And this zone will be known as rarefaction. Rarefaction. So we get a CR, 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 CR zone. So let's see at a particular instance of time t. Okay, children, if you don't understand, do not hesitate. Thoda tough topic hai. At an instant t, first we will get CR, 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 CR like this. Immediately the next instance, the very next instance, and our very next instance will be what? Our very next instance is T dash. It will become RC, 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 RC. Are you understanding? There will be compression, rarefaction, compression, rarefaction. How long does this disturbance continue? As long as this person is doing buck buck. So how does the diagram look like? The diagram will typically look something like this. Okay, bear with me. The diagram will look something like this. Let's say this is one zone, and this, in this I will have alternate zones, compression, okay, then I'll have a compression zone, rarefaction zone, compression zone, rarefaction zone, compression zone, rarefaction. So my molecules will become like this. This is zone of compression, so they are all compressed. Here they will all be relaxed. Again compress, 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 compress. Again relax, 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 relax. Again compress, compress. This happens. Immediately next instance what will happen, इसका just उल्टा, ये वाला expand करेगा, ये compress होगा. Are you understanding? So if you, so let me copy this so that it gives you an idea. Now let me copy this and bring it here. The immediate next instance what you will see is, the very next instance that we will see, we'll see something like this. Okay. The very next instance we will see, this has become rarefaction, compression, rarefaction, compression, rarefaction, compression, like this. The guy, so when particles are close to each other, compressed, relaxed, rarefaction, compressed, rarefaction, compression, rarefaction. Here we see rarefaction, compression, rarefaction, compression, rarefaction, compression. These are not different drawings. Please understand, the same things, two different time impression I am drawing. At a time t aisa hai, the next time it is like this. How to make you understand better? Let's take a series of a Diwali lamp. When you first see it, I was glowing. Immediately I'm off. Again I'm glowing. I'm off. Again I'm glowing. I'm off. Do you understand? So imagine me as the first section, compressed, rarefaction, compressed, rarefaction. This is my job. As I'm getting compressed, the one beside me, rarefaction, compressed. So when he gets compressed, this fellow is getting in rarefaction. What is the fellow beside? Compression. So if one is in compression, 3 will be in compression, 5 will be in compression, 2 will be in rarefaction, 4 will be. Immediately role change over. Now try to map this with the Mexican wave. What is this? What is, if you take this as person 1, what is the role he is playing? Compressing, rarefaction, compression, rarefaction. In Mexican wave, what does he do? Put your hands up, put your hands down, put your hands up, put your hands down. At a regular interval, he is repeating. To the person on the opposite side, this is appearing as a periodic disturbance. This is how mechanical waves propagate. One of the example of mechanical wave is means sound waves. I'm typically taking sound wave. So in sound waves, we always say sound waves are also known as pressure waves. How long can this disturbance go? The intensity depends upon at what intensity this person is speaking. If the frequency of this person speaking is very high, this disturbance can travel to a long distance. Are you understanding? अगर इसके बोलने की frequency means ऐसे बात करता है ना, बहुत दूर से सुनाई देता है, tweeter sound, then this will go far off. And if its frequency is less, it's like you are tickling very slowly the first child. Maybe the disturbance propagates only till the seventh child. Our job is to make all of them wriggle. So how do you do that? एक बच्चा को जोर से and keep on tickling, keep on tickling, keep on tickling. धीरे-धीरे आप देखोगे disturbance जाना शुरू हो गया है. We study this again. Sound waves we will be studying in sound chapter. My idea was to make you understand what is a mechanical wave. A mechanical wave is that wave which needs a medium for propagation. Every wave will create alternate zones of periodic disturbance. In sound wave, we call these zones as what? Rarefaction as well as compression. Rarefaction, compression. That means going further, if I try to plot the sound wave, then if I'm showing the compression with a crest, the rarefaction will be shown with a trough. Does this make sense? So again we will have, after that again we will have a rarefaction. These are पढ़ेंगे हम लोग ये सब. अब आपको धीरे-धीरे just develop कर रहा हूँ. This is wave motion. You have to have some sort of a periodic disturbance. Let us take it with the Mexican wave in the stadium. Hands up, crest, seated down, trough. Hands up, crest, seated down. And they're doing it at a periodic interval, regularly. Wave propagates. So what did we learn? We learned that on the basis of the medium in which the wave propagates, we can call them as mechanical waves, or we can call them as electromagnetic waves. Electromagnetic waves also we have a chapter, sound waves also we have a chapter. What are mechanical waves? Any wave which needs a medium for propagation. You take a piece of stone and you throw it on that lake and you see the ripples going. The ripple is a disturbance. It goes on what? The water. The water is the medium on which the ripple is propagating. Is it a mechanical wave? Yes, it's a mechanical wave. This was the first way of classification. The next way of classification, आइए. और इन दोनों का कोई तालमेल नहीं है. Okay, there is no relation because children confuse a lot. The next way, before understanding, we have to understand that periodic disturbance, any sort of a periodic motion, say we can correlate a wave, right? Now this periodic motion, one way of this periodic motion can be a vibratory motion. That means vibratory motion can also give me a wave, right? So my second way of classification, and the two classifications do not have any interlink between them. You will see some sort of waves which are classified here also. The first one was only on the basis of medium. Please do not bring medium is a different way of classification. And the way we are learning is completely different. We will see certain waves which are falling here also, there also. हो ही सकता है. So periodic motion gives me wave. Vibratory motion is a periodic motion, so it should also give me a wave. Now the question comes, in this vibratory motion, what is vibrating? The particle is vibrating. Particle vibrates. And our next way of classification will be on the basis of the manner this particle vibrates. ये कैसे vibrate कर रहा है, इसके manner पे we will come to a type of wave. Understood? Okay. So let's say that there is a wave which is represented in this manner, and the wave is propagating in this direction. How do you say, sir, wave is propagating? Simply go to the gym, take the rope and do this thing. You can see the wave propagating in this manner. Now, if your particle, number one, if we have a particle and this particle has to vibrate, and it vibrates perpendicular to the direction of the wave, then such a wave will be known as transverse wave. A transverse wave can also be an electromagnetic wave. It can also be a mechanical wave, because that classification is based on method of medium used. This classification we are talking that if the vibrating, if any periodic motion is going to give me wave, vibratory motion is a periodic motion. वाइब्रेटरी मोशन में क्या होता है बेटा, कोई पार्टिकल वाइब्रेट करता है, अब उसका वाइब्रेशन कैसा है, अगर उसका वाइब्रेशन, सो इन ब्रॉड सेंस वी आर ट्राइंग टू से इट लाइक दिस, that if this is the direction of my wave, if this is the direction of my wave and my particle is vibrating, particle jab vibrate karega, so definitely the particle has to vibrate. Vibrate means it has to vibrate up and vibrate down. If the particle vibrates up and down, that it is perpendicular to the direction of propagation of wave, such a wave will be called as transverse wave. Let's see a very nice example, the same example that I gave. I'm in a gym, I have taken the ropes. How am I shaking the ropes? Up and down, up and down. How is the wave going? Transverse wave. Did you understand what is a transverse wave? Okay, next thing. Let's say in my car, I have something which is a spring. In my car, I have a spring-loaded Mickey Mouse. As a spring area hai, and there is a Mickey Mouse on top of it. Okay, there's a Mickey Mouse on top of it. अब इसको दबा देने से, just see, if I press it, if you press this, this is, say, we will say that, let's say, let me bring the Mickey Mouse to the datum here. Let's say, this is, say, my Mickey Mouse. Okay, look at this is the baseline of the Mickey Mouse. Now what do? You compress this Mickey Mouse and you leave it. So what do you observe? You will observe ये Mickey Mouse अपने level से ऊपर जाएगा, somewhere up, and somewhere it will also come down. Don't you see that? It's a spring. A spring, if it is compressed, this is the normal level. This is the normal level where the spring is. If you compress the spring, then what do you see? If you compress the spring will actually come here. You have compressed it. Now if you release it, it will go up till here. Do you agree? That means the spring goes this much up and the spring comes this much down. That's its amplitude. This was my central position, mean position. The maximum, this was the Mickey's central position. The maximum deflection on either side of vibration by a vibrating body. Who is vibrating? Mickey is vibrating. Have you seen on dashboard some Mickey Mouses are kept? So the Mickey right now is where? The Mickey Mouse is right now at its mean position. Mickey Mouse ko daba diya, negative amplitude, because we are going down on the y-axis. Release the spring now. Now Mickey doesn't return to the mean position. Mickey goes beyond the mean position. Positive amplitude. Negative amplitude, positive amplitude. You take a cycle. What does your cycle have? The between cycles that we have, there was shock absorbers in them. See, so much nice is physics, okay? Now, if we did not have shock absorbers, what will happen? Suppose you are riding a cycle and you get into a ditch or a pothole. The entire cycle falls into the pothole, so it will give a force on that rigid road. The road will give you a rigid force back, and you get a huge pain or a strain on your arms. So what we did on our cycles, we have fitted shock absorbers, which are nothing but springs. So as we go down in the pit, we actually go down more. And by the time the cycle comes above from the pit, the spring also opens up. Your ride becomes much more comfortable. Do you now understand why springs are there? Sofa mein hum spring dete hain. If the spring is there on the sofa, what is the good thing? When you just go and sit on the sofa, you have a body weight, so you will be compressing the spring. You don't feel a jerk immediately. You don't feel a jerk immediately on your hips. Baithte jerk lag gaya. Like if I make you sit on a wooden table or a wooden chair, would you just go and rest on the wooden chair? No, aapko dard ho jayega. But sofa mein you will compress it. Then what will happen? The compression will again give rise to an extension of the spring. It will lift your body up and you feel very much comfortable. That's the job of a shock absorber in a cycle. Have you seen in a cycle we have got shock absorbers? In bikes we have got shock. In a bike, if you see the wheel, you have got two steel rods out there. What is there? You have oil out there. And the shock absorbers will go with you. When you go into the pit, you actually go more with it. And by the time the wheel comes out of the pit, the spring also opens up. So you hardly feel that आप किसी गड्ढे में गिरे थे. So what we try to explain here is that if a body is vibrating perpendicular to the direction of propagation of wave, such a wave is known as transverse wave. Is it clear? So if I make my diagram a little bit more cleaner now, let's say I'm making this diagram cleaner. So I would say that out here now, I will have, let me make two more lines. 1 minute. Let me make two more lines. So this is one line and this is one line. Can you correlate what are these two lines right now? The wave will always start from the mean position of vibration. The body is here. This is the head of Mickey. Mickey compressed. Mickey's head comes here. Mickey released. Mickey jumps still here. Again, Mickey goes here. Mickey comes here. So what are these lines representing? Amplitude of vibration. So if this one we call as, if this is called as plus A, this will be minus A. Body is vibrating in this one. So if you see a seagull or anything, the seagull is vibrating up and down, as I told you in the first day. When you go to a seashore, the wave travels to you, but that seagull doesn't come to you. Seagull वहीं पे है क्योंकि पानी तो वहीं पे ही है. So the motion is perpendicular. Is this clear? Have we understood what is transverse wave? Don't confuse. Now question arises. Sir, you gave an example of sound. Is sound a transverse wave? I will say no, but sound is not a transverse wave. Oh, then you mean to say that in sound, the particles do not vibrate in right angles to the direction of motion of wave. If I am talking to you, my sound wave is reaching you. So the direction is this. And you said, sir, that sound is not a transverse wave. Yes, sound is not a transverse wave. That means the vibration is not perpendicular to the direction of motion. Itna samajh mein aaya. Sir, can you give an example of something which is a transverse wave? Well, why not? Take a stone and just pelt it on a lake. Don't you see the ripples going? The ripples are also actually vibrating up and down. How do the vibration, what is the vibration? The vibration is up and down. But you see the ripple going in this direction. Water wave is a transverse wave. Ripple's best example is put a leaf. You feel that the circles are radiating outside. No, disturbance is radiating outside. If the circles were radiating outside, the leaf would have separated away from you. The leaf doesn't separate. The leaf remains there. What happens in a ripple is that sometimes the leaf will come up, sometimes the leaf will come down. Sometimes it will be at its same position. So how is it oscillating? Up and down, up and down. How is the wave spreading? Perpendicular, radially outwards. Radially outwards, whereas it is like a tangent on that particular circle. The leaf is going up and down and the ripple is spreading. Have you understood what is a transverse wave? Now again question arises. That means you mean to say, sir, all transverse wave are what do you call mechanical waves? No, nothing like that. These two comparisons are completely different. Light is a transverse wave. In the case of light, the vibratory particles are vibrating at perpendicular to the direction of motion. Light is a transverse wave, but light is not a mechanical wave. So be very careful when you are comparing between mechanical waves. Mechanical and electromagnetic waves are compared on the basis of medium through which they travel. Transverse and another form, which I'll say now, are actually compared on the basis in which the vibration or the disturbance is happening as compared to the direction of propagation of the wave. Have you understood this? Right. So we come down to the next type. So the first one was that particle vibrates perpendicular to the direction of wave. One of the best example is the gym rope. You are vibrating in this direction. The wave is propagating in this direction. It's a transverse wave. Okay, let's see the next example. Okay, let's take the next example now. So take the next example, we will take it here itself. Okay, the next example is, this was perpendicular. Number 2, we say, if you vibrate to and fro on the same axis as the axis of wave propagation, then such a wave is known as longitudinal wave. Longitudinal wave. Longitudinal waves, the particle undergoing vibration vibrates along the axis of propagation of the wave. Matlab kaisa? Right now, sound wave, how is the sound wave going? Look at me. If I'm speaking, the wave is traveling from me to this window. So what is the direction of the wave? This. The particles, who are the particles? The air molecules. The air molecules in case of sound wave do not vibrate like this. They vibrate like this. See. Compression, rarefaction, compression, rarefaction. Such a wave is called longitudinal wave. To give you a pictorial view, transverse wave kaise proceed karta hai? How does a transverse wave go? This is transverse wave, water wave and all. How does a longitudinal wave go? Wave is going in this direction, particles, but I'm moving because I have to show you, but no particle changes its position. The particle just does. This is longitudinal wave. And if I'm transverse wave, at my place only, I will not, because matter doesn't move in wave. It's just the disturbance propagates. So in transverse wave, when I'm up, fellow next to me say Dhruv, he's down. When I'm down, he's up. Periodic. Transverse wave. When I'm stretching, Dhruv is compressed. When Dhruv is stretching, I am compressed. Compression, rarefaction, compression, rarefaction, compression. So compression, rarefaction, same again. Rarefaction, compression is happening in this way. So a sound wave is a classic example of longitudinal wave. Is a sound wave a mechanical wave? Yes, it's a mechanical. Why? Because sound needs a medium to travel. Is it a transverse wave? No, it's not a transverse wave. Understood? So, sir, can you give one example which fits into both? This is many times asked. One example which fits into both. Well, if you want that example, then you need to understand something which is called a slinky. Do you know what's a slinky? नहीं जानते तो कोई बात नहीं. That spring, चूड़ा जैसे होता है ना, चूड़ा type. A slinky is a spring which is like this. A long spring. This is a slinky. This is slinky, right? Now what do? You bind the slinky on one side, fix kar do ek side mein, and then on one side you start doing this. So you will typically see a wave motion created like this. It is easy for me to draw. The slinky will go like this. What sort of wave we have created? Anyway, mechanical wave, because we need the slinky for the wave to go. It's a mechanical wave. The first one is known as transverse wave, because in this case, I will be moving the slinky up and down. It goes like this. The second time, same slinky. Now what do? You keep the slinky straight. Just खींचो और छोड़ो ऐसे करके. Now you will see like this. Are you getting the idea? Now what is my direction of periodic disturbance? This. What do I see here? Compression, rarefaction, compression, rarefaction, compression, rarefaction. This was a photograph taken at a particular instant. But if my student Srinika madam is watching this from a distance, she will see ye compress ho raha hai, next moment ye expand ho raha hai. When it is expanding, this one is compressing. It's just like a light chaser. Bulb 1, 3, 5, 7 glow at the same time. 2, 4, 6, 8 glow at the same time. That is the principle of a chaser. If I do this glowing more than 1/16th of a second speed, then your human eye can be fooled. So you see what? One light is glowing, tick, 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 going this way. Na, aisa nahi hota hai. Nowadays we are watching, how are we watching cinema? We are watching cinema by a file system. Earlier cinema used to be as a film, Have you seen when a movie shoot happens, what does the director say? Roll camera, start sound, action. Why do they use the word roll camera? The camera used to be a continuous camera with a roll film. The roll will means if you are moving your hand to pick up a phone like this, the camera might be clicking 10,000 images, all continuous, and they are all in a film. Now this film is moved in the projector at a speed more than 1/16th of a second, then your human eye has got a very good property called persistence of vision. If I show you something, the image of thing remains in your head for 1/16 till the time I show you the next thing. That is called persistence of vision. Some waves say. So by the time I show you the first position of the phone being lifted, immediately, very quickly, I'm showing you the next image. पहला image निकला ही नहीं, दूसरा image आ गया. अब आप क्या देखते हो? As if the actor is moving his hands on that screen. If you want to test it, go to the projector room and slow down the projector. You'll immediately see rolls coming out on the screen. Our human eye. Televisions that we use nowadays are LED televisions. If you see that straight box type movie television, which might be there in your ancestral house and all, they are on refresh rates. Refresh rates means, if you, I don't know how many of you have done those experiments. If you take a video camera and you put it on the television screen, you won't see the television screen continuously. You'll see films being rolled. Are you understanding what I'm saying? Human eye can be fooled. Camera cannot be fooled. Those are called refresh rate. That's why we used to say the refresh rate is so and so. So if the screen refresh rate is faster than the camera's refresh rate, then you can't pick that. Remote controls. How do you know your remote control is working or not? Science SSCK. What are these remote controls? This one. These are IR remote controls. This has got an IR sensor. How do you know this remote control is functioning or not? By changing battery. Simply start the mobile camera and put the mobile camera in front of it and then press the remote. You will be seeing the light. It fools your eye, but it can't fool the camera. आप कैमरा ऑन करो और इसके सामने इसको ऑन करते रहो, आपको ये लाइट दिख जाएगा. That is the proof. So like in science museums, if you go, you get, physics is all about discussion. See, in science museum, if you go, you'll find one, in the garden, you'll find one apparatus kept where there will be oval shaped card, an oval shaped card, something like a U, solid U. On one side of the U, they will make one parrot. And on one side of the U, they will make a cage. And there will be a handle. If you return the handle, so you see the parrot, the next turn you see the cage. Now they will tell you, थोड़ा और जोर से घुमाइए, और जोर से घुमाइए. क्या देखोगे आप? Parrot inside the cage. Persistence of vision. When you turn it slow, I see parrot image gone. Then I see cage image gone. Now you're turning it faster and faster and faster and faster. So I see parrot cage. So what do I see? Parrot inside a cage. No, you'll see the parrot inside a cage. It's very beautiful. Whenever you go to a place where people go to Goa, they go to beaches and all. Goa has got a lovely science museum. Please go. Kolkata, if you are there, there's a science museum. Science museum जाएगी जो है बहुत सुंदर चीज आपको देखने को मिलती है जो real life में you'll not be able to see. Like here we have Birla Planetarium, some things are there. So do you understand now what is a transverse wave? So in last class we discussed about wave, what you call the wave is a periodic disturbance, and we understood it from an oscillating body. Now we'll be going through this. So your book has got something called a progressive wave. A wave, what is a progress? Now there is another word called progressive wave. What is a progressive wave? Any wave which carries energy along with it. Sound wave is a progressive wave. Sound waves are also known as pressure waves. A wave carries energy from one place to another place. Once the energy dies down, the wave dies down. Can I be heard from L tower right now? No, because the intensity of my sound wave does not carry that much energy. If I'm using an amplifier, the energy is more. It does reach out there. Or else another way that I can make my voice reach is convert karo. Convert my sound waves. What are these? Mechanical waves. What waves? Longitudinal mechanical waves. Use a microphone and convert them into what? Electromagnetic waves. Right? And then send it through the ionosphere where there are no medium. And now broadcast it into London. Radio. Again, there change it back to a sound wave. You are taking my voice to another place. That's why they say that in the world of internet and all, you know how you see internet? That is all by undersea cables. I hope you know that. Across continents, there are a huge number of cables laid. Russia is now snipping many cables, causing a problem to NATO nation. Suppose and satellite communication. Satellite is the fastest communication. The way we see actually Star TVs and all, how are we watching Star TV? That it's being reflected to a particular satellite, and the satellite comes directly on my dish antenna and I view it. Sab kharab ho gaya, everything gone. How will you communicate? Radio. Radio can never die. Right now, there are a lot of what you call, the Russian media is banned outside after this war with Ukraine. There are many British people who are still in Russia, but they can't see the British media. So they have to see what the Russian media shows them. So how do they hear about what is actually happening in the world? So if you open MSN and all, these are Americans. So they always show that, Russia is losing the war. If you go to Russia, you will see Russia is winning the war. But if a British guy inside Russia wants to listen what is happening in the outside world, he doesn't have cable TV now, like you and me. That's why the BBC has restarted its radio services. Radio ko koi nahi rok sakta hai. I don't know how many of you people know, Netaji Subhash Chandra Bose was put under a house arrest by the British. That is the biggest slap on the face of the British. He was put under a house arrest. He disguised, came out of his house in Kolkata, went till a place called Gomo in Bihar, took a train, went till Peshawar, Lahore to Peshawar, then crossed Afghanistan, there, Europe, everywhere, and then lands up in Germany, and then speaks on Deutsche Radio for the first time. This is Subhash Chandra Bose speaking, and that's a slap on British face. Uske aankh ke samne nikal ke. So how people used to communicate? Radio. What type of wave? Electromagnetic wave. What is the type of propagation? Transverse. So please confuse mat hoiye. In your case, a transverse wave is a electromagnetic wave. Okay, very good, understood. A water wave is a transverse wave. A sound wave is a longitudinal wave. And longitudinal waves generally need a medium to go. That's it. However, a slinky can be made to show both waves at the same time. You can show longitudinal as well as transverse. But both these waves are under which class? Mechanical, because both of them are needing a medium to go. Bhai bolo, yahan se aur koi cheez aapko disturb karta hai? So tell me one thing. As you have understood, I'm going to write some words. And Ashmita बेटो एकदम freely बोलना, आप ये words को समझते हो कि नहीं अभी?
Yes.
Wave. I'm writing some words. Wave. Then I'm writing mechanical. I'm just writing the word mechanical. You should understand it's mechanical wave, electromagnetic wave. Then I'm writing transverse. I'm using the word longitudinal. Then I'm using the word compression, rarefaction. I'm also using a word called progressive wave. देखो तो बच्चा, this word, any word feels alien to you now? Just check once till we go one level more. Any wave which carries energy with it is called progressive wave. Sound wave is a progressive wave. Sound wave is carrying my energy. Sound is a form of energy. Sound is a form of energy. Yes or no? When a bomb explodes, what does it give? Heat, light, and sound. That's why they say that during the war of Mahabharata, all these sounds that were created, they were all sound energy. They got lost into the environment, but can energy get lost? No, energy can only get converted from one form to another. If there is one mechanism one day that we can convert the form in which those sound, what Krishna might have spoken or other people, if we can convert that back to sound energy, we should be able to hear those in today's world also. You might be thinking I am talking absolutely rubbish. So let me give you one more example. You know about Akbar the Great? He was a Mughal emperor. In Akbar's court, there were 9 jewels. Navratna bolte the unhe. Birbal was one. Tansen used to be one. Tansen, they say, he used to be the king of Rag. Tansen गाना गाने से बारिश भी आ जाता था. So Akbar used to listen to Tansen a lot, and he gave more rags. And let's take Sahasra from here and let her make her time travel back to 1600 or 1500 AD, 1529, and she is now in the court of Akbar. And Akbar says, हमें बहुत दुख महसूस हो रहा है, तानसेन को बुलावा भेजिए, हम गाना सुनना चाहते हैं. and this fellow could not keep her self control. She says, जहापना, आप उनका एक MP3 रिकॉर्ड करके रख लीजिए ना, आप उनको क्यों डिस्टर्ब करते हैं? जब जब चाहे आप तानसेन को सुनते रहेंगे. She is speaking sense. Akbar says, इसे काल कोठरी में बंद करो, इसकी ये गुस्ताखी. How dare she speaks? All nonsense she is speaking. At that age, that was nonsense. What I say? My grandfather could never think that he could see himself, people could see himself after he has died. Today, video camera and video cassettes are there. So who knows, one day we might be able to extract those voices. So science ko kabhi bhi kamzor. Science is all about exploring, exploring, exploring as much as you have explored. Sound is a form of energy. So you now understand what is progressive wave? Okay, right, fine. So now since we have understood all these things, it's time for us now to go into an actual schematic of a wave. So our wave, as I told you, can be shown in two schematics. One is we can show the wave as a function of distance and one as a function of time. One as a function of time. So we'll draw two waves out here, okay? Rather, let me draw one wave and then replicate the other one. So fine. So since my wave starts from here, so I should also have a reference point. So let's say this is my reference point, okay? And I need to give two amplitudes to this wave. So let me give two amplitudes. Say this is my positive amplitude, okay? And this is my negative amplitude. ये जो आप पढ़ रहे हो ना trigonometry में sin theta, sin theta, sin theta, the sin x function is also a wave. Y equal to sin x is a function that is also a wave. You'll see that sin theta's maximum value is always from +1 to -1. So what is the amplitude of sine function? +1 to -1. Sine का value उससे ज़्यादा कभी होता ही नहीं है. You can not get any value of sine which is more than 1. Whatever value of angle you take. Okay, so this is my plus amplitude. So how do I write it? I will write this something like this. Say this is my zero level. So this is my plus amplitude and this is my negative amplitude. ठीक है बच्चा, समझ में आया? Right. And then I start plotting my wave. Wave को किससे दिखाएं? Yellow, 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 red, red से दिखाएं. Red bold. This is my wave. चलेगा.
So this is simply an option. This is an option for.
No, that option I can take, but the reason is then you will not understand the beauty part of it. Okay? This is a wave. Now let me copy this. Now let me copy this and bring it down. Why did I do this? As I told you, one we will see as a function of displacement, one we will see as a function of time. Okay? So let's see as a function of displacement. Let's say the first wave is a function of displacement. This is x and x is in meters. And this is a function of time. T is in seconds. समझ में आया? Same wave. And this is the wave of a Mickey. Mickey is vibrating up and down. So this is typically representing, say, a transverse wave. Okay, let's understand. So some of the namings that we need to get correct now. What is this, children? This is known as your amplitude. This is my amplitude. Are we fine? All the portions where you are above the mean position, these are known as my crest. बाकी definition आप book से देख लेना. यहाँ pictorially समझो, वो ज़्यादा important है. These are known as my crest. क्या? Srinika feeling sleepy? Okay, these are my crest. And if there's water here also. If you have your bottle, don't worry. And all the portions below, these are known as my trough. 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 ठीक है? Trough. Till the time, let me say, let's make it more interesting. Let's say this is representing a pendulum. Pendulum goes here and pendulum goes here. ये समझ में आ रहा है बेटा? ये समझ में आ रहा है? Pendulum is oscillating. See, pendulum is oscillating. And we are trying to put that oscillatory motion in terms of wave. As the pendulum goes from the mean position to the extreme and returns back, that is, as the pendulum goes here and comes back, this is known as half cycle. Jana ana. This is half cycle. Not that only the crest, the trough can be also the half cycle. Because ये pendulum का ऊपर का आना जाना दिखाया. Pendulum तो यहाँ भी जाएगा, यहाँ से भी आएगा, ये भी एक half cycle. So a trough also forms a half cycle. Did you understand? Clear? Pendulum toy toy. तो कैसा होता है? Toy means कम, less से ज्यादा, less से ज्यादा, फिर less, फिर ज्यादा, but in opposite direction, फिर less. Are you understanding? This to understand in time is more easy. See, sir, why did you make the wave propagate? That is also a question. Wave जा क्यों रहा है? We started this job at 8 o'clock. 801 second it went here. That is here. So the time starts at 8 o'clock. This is 8 say 01 millisecond. 02 millisecond it comes here. 02 millisecond it comes back. 03 it goes here. 03 it goes here. 04 it. Time तो चल रहा है. आप रोक थोड़ी सकते हो. Versus time. And if we would have wanted to show that our friend Sahasra was doing this thing in gym and she created a wave, the wave was traveling. What distance did the wave travel? I need to plot the wave in terms of displacement. Got it? Okay. One. So now see what I'm doing. One half cycle and one full cycle constitute which is known as one cycle. ये क्या हो जाएगा बेटा? ये हो गया हमारा one cycle. This is my one cycle. This is from here to here. This will be my
Sir,
yes sir.
my question is.
हाँ बिल्कुल बिल्कुल एक मिनट मैं सिर्फ one cycle लिख लूँ. One second. हाँ बेटा बोलो.
So, nothing for distance you're plotting like how far the disturbance travels.
How far the wave is going? Because my pendulum बेटा वो तो अपनी जगह पे टंग 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 कर रहा है. But it has created a wave. The wave is going on moving.
So the particles will move the distance you're plotting.
हाँ the disturbance. यहाँ particles का कोई बात ही नहीं है. This is not particle. This is the very good question. This is the plot of the disturbance, not particle. No particle moves in a wave. You can also think it about as the ocean water, which Dhruv was having an assumption that the water actually travels. The water does not travel. This is the ocean water. ये पानी यहीं रहता है. बिट्टू, ये 8 o'clock का snapshot है. 1 millisecond, the snapshot will be just the mirror image. ये वाला crest पे आ जाएगा, ये trough पे चला जाएगा. But our Dhruv and we all feel कि wave वो पानी हमारे पास आ रहा है. पानी नहीं आ रहा है. Disturbance आ रहा है हमारे पास. This is a snapshot at a particular time. Immediately next, ये नीचे आ जाएगा, ये ऊपर आ जाएगा. Alternate. Always remember periodic and alternate motion. तभी ना vibratory होगा. So this is one cycle. That means one cycle is also equal to one crest plus one trough. One cycle is also equal to one crest plus one trough. Have you understood? Now, this sort of explanation that I gave you, pendulum or a spring, I am trying to show what? Transverse wave motion. पर wave तो longitudinal के लिए भी हो सकता है, sound wave. In longitudinal wave, like say suppose if this was the to, then this was the fro. Have you understood? This is for a transverse. In longitudinal, if this is representing compression, this is representing rarefaction. ऐसा भी हो सकता है. Because a wave is not limited to only transverse wave. It can also represent longitudinal wave. Have we understood? Clear? Any doubt? Very good. Okay. So you understood amplitude on this wave. Another thing that we need to see out here is one cycle, that is one crest. Now at this juncture, children, let me not mutate the diagram too much. Try and understand. Say at this juncture, where, which color do I take? Red. No. Yes. Okay. At this juncture. At this juncture, where we just completed one cycle, this will be some displacement of the wave. Displacement means what? Shortest straight line distance. Wave yahan se shuru kiya, wave yahan tak aaya. This displacement is denoted by the Greek symbol lambda. We call it Greek symbol lambda. Lambda. Lambda stands for wavelength. What is wavelength? One full cycle. The distance moved by the wave over one full cycle is known as one wavelength. What is half wavelength? The distance moved by the wave in half cycle. अच्छा बोलो तो half wavelength क्या होगा? Half wavelength can be any crest, any trough. Do you understand? Okay, one more thing. If I add up this trough and if I add up this trough, this also will be one wavelength. पास पास नहीं हो रहा है, वो बात अलग है. ये भी एक wavelength है, only this much and this much. This is all. So in other ways we can say these are all lambda by 2, lambda by 2, lambda by 2, lambda by 2. Do you understand? Half wavelengths. एक crest है ना, एक cycle पे एक wavelength. What is one cycle? One to and one fro. Sir, you are so, biased for transverse. You don't love longitudinal wave at all. Okay, one rarefaction and one compression, one cycle. So here, this will be lambda by 2. Similarly, this is also lambda by 2. Did you understand? Okay. But I don't want to write this lambda on this wave because this wave has been plotted on the time scale. तो टाइम स्केल में है तो इसमें टाइम का चीज प्लॉट कीजिए. क्या प्लॉट करेंगे? लेट्स कम. सो व्हाट डू वी डू? वी मेक अ मार्कर आउट हियर. Okay, now you have to tell me, what does this marker show? This is the time in which one cycle was completed. So this is the time period of the wave. This is the time period of the wave. T. अभी clear हो रहा है? Because in this time you completed one cycle. So what is this? Half the time period. Are you understanding? So in one time period, how much does a wave move? 1 lambda. In one time period, how much does a wave move? 1 lambda. Clear na? When the time struck t, the distance moved by the wave was lambda. Clear? बहुत अच्छा. And the next one, I'm making an assumption. So please allow me. If t is equal to 1 second for this case, I'm saying for this case, मतलब ये t ये है 1 second. तो ये कितना होना पड़ेगा? ये 2 second होएगा, है ना? ये कितना होएगा? ये 1.5 second होएगा. ये कितना होगा? ये 0.5 second होएगा. Clear? In 1 second, how many cycle did you make? 1 cycle. So the wave that you have designed with me today has a frequency of 1 hertz because it completed 1 cycle in 1 second. चाहने से ये चैप्टर आधा घंटा में पढ़ा सकते हैं, लेकिन क्यों 2 क्लास लिया? Because आगे जब भी आप साइंस पढ़ोगे, you will need this. If this basic doesn't get clear, 1000 रटने से भी नहीं होगा. Now you can solve even higher grade questions. So in one, but this is a pure assumption, okay? This is a pure assumption. It need not be. Okay, now tell me one thing. If 1 second would have happened here itself, then what is the frequency? 0.5. I complete half cycle every 1 cycle. I am slow. I am slow. So what is my frequency? My frequency is in 1 second I am completing only half cycle. My frequency is half. Do you get it? Now say suppose this was 2 seconds. 2 seconds. That means in 2 seconds I am completing one cycle. So in 1 second I am completing half. अब उल्टा करते हैं, इसको अगर यहां पे 2 बना दिया, इसको 0.5 बनाते हैं, 2 नहीं, make it 0.5. So in 0.5 second I have completed one cycle. That means in 1 second I will complete 2 cycles. My frequency is now 2 hertz. So how do you show a 2 hertz wala graph? Zara dekhte hain. See, Srinika. So let's say this is you. So you playing the keyboard and you're playing on low scale. Your frequency is this. 1 second में 1 cycle होता है आपका एक chord का. But I am Gen Alpha, too much of energy. I sing at higher scale. But our melody will be the same. So I need to complete how much? 2 cycles for her time period. थोड़ा ज्यादा हो गया. Do you see? In 0.5 seconds, I completed one cycle. That means my frequency is double than you. My frequency is 2 hertz. White, the blue frequency is 1 hertz. The yellow frequency is 2 hertz. Do they sound different? No, in a piano, this is the middle C, this is the next C. Double the frequency of this. Acha. Which sound will travel far? The yellow one will travel far. If I have a boy and a girl, who is the boy? The blue is the boy by nature. The yellow is the girl. If I have a kid and an adult, the kid is the yellow one. चिल्लाता है, दूर तक जाता है. Adult. If I have a boy and a baby girl, the yellow is the baby girl. The blue is the baby boy. Boys do not have that much of frequency. And I don't know whether you know, human beings can hear only from 20 to 20,000 hertz. That is the audibility. We'll study this in sound chapter. Human beings hear only from 20 to 20,000 hertz. But when you are a baby, you hear above 20,000 hertz also and below 20 hertz also. That's why when baby means ekdam baby, just born, they come and they sleep. If you want to go and see the baby also, people will say, if you even sit beside, if you are sleeping and I go and sit beside you, you will not wake up. But if you just go and sit beside the baby, they can hear. Babies can hear. And sounds which are below 20 hertz are known as infrasonic. Infrasonic. 20 to 20,000. चलो इसे बाद में भी पढ़ेंगे, but थोड़ा पढ़ लो. 20 hertz to 20,000 hertz. This is the human audibility range. So any sound in this frequency, we call it sonic. Sonic. Any sound below it, infrasonic. Any sound beyond it, ultrasonic. No, not supersonic. Ultrasonic. Supersonic is more than the speed of sound. Have you watched Maverick, Top Gun? So they say na Mach 1, Mach 2, Mach 3, Mach 4. Mach 1 means 1 times the speed of sound. So what is the speed of sound in air? Speed of sound in air, 343 meters per second. So when you're going at Mach 8, means you're going 8 times the speed of sound. BrahMos is a supersonic missile. It goes more than the speed of. सुनने से पहले मार के जाएगा तुम्हें. Supersonic. Subsonic means you are below the speed of sound. So all these aircrafts and all, so what is the speed of sound in air? 343 meters per second. A Jet Airways aircraft or an Indigo aircraft flies at what speed? Subsonic, less than the speed of sound. Whereas a Rafale or a MiG-29 will fly supersonic jet. It flies more than the speed of sound. Speed, this is frequency. Anything below this is known as infrasonic. Anything more than this is known as ultra or ultrasonic. Rhinoceros communicate with each other with infrasonic sound. Maybe Kirtan also communicates in infrasonic sound. Rhinoceros, you know, a rhino proposes another rhino through infrasonic sound. We can't hear it. Bats fly by making ultrasonic sound. Have you seen, in Ratnadeep also it was available, there are some rodent repellents available which can be plugged. that rodent repellent, like if you go to, like if you go to Big Basket, a Big Bazaar, or you go to the Amazon warehouse and all, there are a lot of perishable items kept, like rice grains and all. So rats will come. What they do, they have a lot of ultrasonic repellents. These ultrasonic sound repellents, we don't hear them at all. But when a rat comes, for the rat, it is, he just gets out of that place because the noise is much more than the audibility range. इतना छोटा सा एक चीज होता है, ऐसे लगा के रख दो, that's an ultrasonic sound generator. ये जो पेट में अल्ट्रासाउंड करता है ना, if anyone has undergone an ultrasonography, anytime, anyone has an experience of undergoing ultrasonography? No, not yet. Very good. You should not have also. So even as a part of health checkup, you will undergo. So in an ultrasound, the doctor will put a jelly on your tummy and put the probe. As soon as the probe is put, your imaging starts. That is ultrasound. आप सुनते नहीं हो. Supersonic and infrasonic is with speed of sound. If you travel at speed of sound, it's called sonic. Below that, subsonic. Above that, supersonic. And when you become supersonic, then that Mach wala word comes up. Mach 1, Mach 2 and all. Okay, this one is done. Let's a little bit more. Okay, time period dekh liya humne, amplitude dekh liya. Now one more interesting thing. 5 minutes you have to give me because I cannot draw this diagram again. Okay. Now the next thing we need to understand is a concept called kahan likho. Okay, yahan likhta hu. Phase. What is a phase? 2 points on a wave are said to be at the same phase. 2 adjacent points on a wave are said to be the points on a same phase if they have the same trend of motion. Means, थोड़ा समझो, अब ये वाला point कैसा है? It is a point on the latter part of a crest trying to now go down. Its next adjacent nearest similar point, you will say this, ये point ऊपर जाएगा. The next point is this. So if this is my point P1 and if this is point P2, P1 and P2 are said to be in the same phase. So how do you understand it in real life? Look at me. So there is the 26th January parade going on at Rajpath in Delhi. So we are 5 of our people are marching. 5 people on this side, 5 people on this side. On my back, 5 on my back. So when we march, all our right hands move together. Right hand and my right cuffling. The immediate next guy's right hand and right cuffling are moving together. These 2 cufflings are in the same phase. So if you see the marching, the 2 couplings will go up and go down at the same time, periodic. You have done a lot of annual day celebrations at your school. Kiddo level. Let's see kiddo annual day celebration. What happens? You'll always see the teacher at the back side. Now say the world is beautiful. Then all the children will put their hand beautiful. And then at that time, there'll be one Ashmita who will say, world is beautiful. We say, yeah, out of phase there. How to get again? That means this is Ahiri, this is Nidhi, Ashmita यहाँ पे है. जब सब लोग नीचे हाथ कर रहे हैं, Ashmita का हाथ ऊपर उठ रहा है. So we call you're out of phase. And same thing happens when we sing in orchestra. I don't know music. I know music only by signs. So how do we sing? Nowadays, you have got all those digital tuners. Otherwise, I have hired a piano player. I'm a guitarist. He's the singer. We are all mixing up here. But we all know music. The first thing I will ask this girl is, do you play your open E? She plays her open E and I start plucking. And I close my ding, dang, ding, dang, ding, dang, ding, dang. Once this 2 matches, I just tune my guitar. My guitar has gone tuned to her piano. And after this, whatever she plays and when she strikes E major and I strike E major, we are on the same phase. Otherwise, this E can be a little bit tight also, but then all the strings go tight. So my scale and her scale goes differentiated. We will be Besura. And once you have tuned one string in guitar, it is EADGB. Every adult dog growls, barks and eats. बस एक ट्यून हो गया तो एक ट्यून करो, दूसरा ट्यून करो, 5th fret में, 4th fret में. As I say, music is all mathematics. So the same thing happens. Now, one observation that we will get, थोड़ा bear करो, I know you're cursing me, curse me. The distance between 2 points on a phase can also be represented by lambda. This is also one wavelength. So one wavelength can be one crest and one trough, or the distance between two adjacent points on the wave. This is in phase with this, and similarly this is also in phase. सुनो मेरी बात, ये तीनों फेज में है. जब ये डुबकी मार रहा है, ये भी डुबकी मार रहा है, ये भी डुबकी मार रहा है, बट वेवलेंथ ये नहीं है. वेवलेंथ इज टू एडजेसेंट पॉइंट्स इन वेव. वेव इज वेरी इंटरेस्टिंग. ये अभी 10 बजे तक पढ़ा सकते हैं, लेकिन क्या करें, टाइम है और जल्दबाजी में नहीं होता है. आप वो समझ में आया? वंस दिस बिकम्स क्लियर ना, यू कैन गो एंड एक्सप्लेन दिस टू एनी ऑफ योर स्टूडेंट्स. तो ये बड़ा इंटरेस्टिंग टॉपिक्स है. इसके बाद आप ये बुक पढ़ोगे ना, दिस विल कम वेरी सिंपल टू यू. सो व्हाट ऑल डिड वी लर्न? जस्ट लास्ट 2 minutes, व्हाट ऑल डिड वी लर्न इन वेव टुडे? वी लर्न दैट इन अ वेव यू कैन शो एम्पलीट्यूड. You understood what is a crest. If crest shows one side of a periodic disturbance, trough shows just the alternate. If crest is standing up, trough is standing down. If this is the bulb that we have designed, if crest is glowing, then trough is the turned off position. Have you understood? If crest is showing extension of a spring, trough is showing compression of a spring. Crest and trough can also show longitudinal waves, which are compression and rarefaction. One crest and one trough makes one cycle. One crest makes one half cycle. If plotted on the displacement axis, then one crest and one trough shows me one wavelength. And the time taken to complete one wavelength is known as time period. If that time period is 1 second, then the frequency of the wave is 1 hertz. Phase are points on a wave which have the same motion trend. Phase यहाँ पे भी हो सकता है. This is also a point in same phase. Here also if I try to measure, I'll get one wavelength. समझ में आया? बहुत अच्छी बात है. She is desperate to go now. Sir, बहुत हो गया. And then we have shown you frequency. So a sound wave which has more frequency will be more git 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 git. Which has less frequency will be आराम आराम से आएगा. Somebody who has more frequency will be more git 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 git. चलो, बोर हो गए हो तुम लोग.